Okay, Angle Identities, Unit 8, Day 6. So these are double angle identities and half angle identities. We're going to work with the double angles first. So if we're given sine of theta equals 5/3, and theta is between 0 and pi halves, we have to find cosine of 2 theta. So that's in the first quadrant. So I'm going to draw my terminal side in the first quadrant, drop that down, create a triangle. Sine is opposite over hypotenuse, so the opposite side is 5, the hypotenuse is 13. We can find that missing side by using Pythagorean theorem, just like we've been doing this whole unit. So that's x squared plus 5 squared equals 13 squared, x squared plus 25 equals 169, x squared equals 144, so x equals 12. So that right there is 12. Now, cosine of 2 theta, you can either use the cosine squared minus sine squared, or 1 minus 2 sine squared, or 2 cosine squared minus 1. It doesn't really matter, you'll get the same answer either way. I'm just going to use the first one. So cosine equals 12 over 13, sine equals 5 over 13. So I'm going to just plug that in. So that's 12 over 13 squared minus 5 over 13 squared. Well, if we square those out, you get 144 over 169 minus 25 over 169, which equals 119 over 169. And that's your answer for that one. We're all done. Not too bad, pretty easy. It's just finding sine and finding cosine, plugging it in. Okay? So if we're given cosine of theta equals negative 7 over 25, and it's between pi and 3 pi halves, we have to find tangent of 2 theta. Well, that's in the third quadrant, so I'm going to drop that down. Cosine is adjacent over hypotenuse, so that's negative 7 over 25. Let's find the opposite side, so that's x squared plus negative 7 squared equals 25 squared. That's x squared plus 49 equals 625. X squared equals 576, so x equals 24. But that's negative 24 because we went down. That's why the quadrant matters, because that's a negative because we went down. Okay, so for tangent, we have to use tangent. So tangent of theta is opposite over adjacent, so that's negative 24 over 7, which is 24 over 7. Okay, and let's just plug that in. So 2 times 24 over 7 over 1 minus 24 over 7 squared. You could put this in your calculator if you wanted to. You would just have to put the whole top in parentheses, the whole bottom in parentheses. Okay, I'm going to go through the math of how this all simplifies out. So let's multiply the 2 to the top, so that's 48 over 7. Square the bottom, that's 576 over 49. Change that 1 to 49 over 49 so that we have a common denominator. And you get 48 over 7 equals negative 5, or over negative 527 over 49. Write that as an actual division. Division, you can flip that second fraction and multiply. And you get negative 2,352 over 3,689. Simplify that fraction, and that's negative 336 over 527. And that's our answer. We're going to save example C for class. Okay, now let's get into half angle identities. Half angles are, there's just one more step than the double angles. Okay, so we're given that cosine is negative 4/5, and it's between pi halves and pi. So that's the second quadrant. So I'm just going to draw this in the second quadrant. Cosine is adjacent over hypotenuse. So I'm going to solve for my opposite side. So that's x squared plus negative 4 squared equals 5 squared. X squared plus 16 equals 25. So x squared equals 9. X equals 3. So that right there is 3. Now I'm finding sine of pi halves. And it just uses cosine. So I really didn't need to find that opposite side. That was kind of an extra step on my part, just so that we get into the habit of it. That's really why I did it. Okay, so sine of pi halves is plus or minus, and make sure you keep that plus or minus. I'll talk about that after we go through all this math. So plus or minus the square root of 1 minus the cosine of theta over 2. Well, the cosine of theta is negative 4/5, so that's 1 minus negative 4/5 over 2, which is 1 plus 4/5 over 2. Change that 1 to 5 over 5. So that's 9 over 5 divided by 2. Well, if you divide by 2, that's the same thing as multiplying by 1/2. So that's the square root of 9 over 10. You can break that up, so it's the square root of 9 over the square root of 10. Well, the square root of 9 is 3, so that's 3 over the square root of 10. We need to get that square root of 10 out of the denominator, so you get plus or minus 3 square roots of 10 over 10. Now, this isn't just plus or minus. We have an actual, it's either going to be positive or it's going to be negative. We have to look at which quadrant we started in. So we started in the second quadrant, but this is a half angle. So if you take the half angle of anything in the second quadrant, it's going to end up in the first quadrant. Okay, like if you say our angle was 95, half of that would be 47.5 or whatever it is. That's in the first quadrant. If you go closer to 180, say it was like 170, half of 170 is 85, and that's still in the first quadrant. So anything in the second quadrant, if you take the half angle, it will end up being in the first quadrant. Everything is positive in the first quadrant, so my answer is positive. So it's 3 square roots of 10 over 10. Okay, let's do another example of that. So let's do example C. So I'm given that sine is negative 8/17, and it's between pi and 3 pi halves, and I'm asked to find tangent. Well, tangent uses cosine, so I need to find what cosine is. So I'm going to draw this out. Sine is opposite over hypotenuse. Use Pythagorean theorem, so x squared plus negative 8 squared equals 17 squared. X squared plus 64 equals 289. X equals 25, or x equals 225, so x equals 15. And that's negative 15 because I went backwards. Okay, so cosine equals negative 15 over 17. Now our starting angle is in the third quadrant, which means my half angle is going to be in the second quadrant. Tangent is negative in the second quadrant, so my answer is going to be negative. Okay, so I'm just going to plug the negative 15 over 17 in, and I get 1 minus negative 15/17, and then 1 plus negative 15/17. So the top becomes 1 plus 15 over 17. The bottom becomes 1 minus 15 over 17. Sorry. Change that to 17 over 17 on top and bottom. So I get 32 over 17 divided by 2 over 17. Since those are both over 17, I can cancel those out. And you get 32 over 2, which is 16. So the square root is 16, which is 4. But my answer is negative since it started in the third quadrant. You take the half angle, that's in the second quadrant. So it's negative 4. Okay, we're going to save that example B for class. And let's just get into proving some of these. So, we have cosine squared of theta minus cosine of 2 theta equals sine squared of theta. Well, let's choose our double angle identities. Cosine of 2 theta is the same thing as cosine squared of theta minus sine of theta. So, or sine squared of theta. So let's plug that in. So I get cosine squared of theta minus cosine squared of theta minus sine squared of theta. Distribute that negative. So that becomes a minus cosine squared plus sine squared. Those cosine squareds are gone, and you're just left with sine squared of theta, which is what we wanted. So we're good. Okay, let's do this one. So we have cosine of theta plus sine of theta squared And that equals 1 plus sine squared of theta. Let's work on the left side because that's going to be a little bit easier. And I'm just going to distribute this. You can use the box, whatever is easiest for you. So that's cosine squared of theta plus cosine sines plus sine cosine plus sine squared of theta. We can simplify this a little bit out. I'm going to put cosine squared plus sine squared next to each other, and then that's plus 2 cosine sine. Cosine plus sine squared, cosine squared plus sine squared is 1. That's an identity that you should have memorized. So that's 1 plus 2 cosine theta sine theta. And 2 cosine theta sine theta is the same thing as sine of 2 theta. So that's 1 plus 2 sine of, or 1 plus sine of 2 theta, which is what we wanted. That's our answer, so we're good. We proved it. Okay, let's do this one. So we have tangent of theta equals 1 minus cosine of 2 theta over sine of 2 theta. Well, let's work on the right side. So 1 minus cosine of 2 theta over sine of 2 theta. Well, cosine of 2 theta is 1 minus 2 sine of 2 theta. And you could have used any of the other ones too. That's just the one I chose to use. They would work. They might just get a little bit more complicated. Okay. So that's 1 minus 2 sine squared of theta. I'm going to distribute that negative. So that's 1 minus 1 plus 2 sine squared of theta. Those ones cancel, and I'm just left with 2 sine squared of theta. And then sine of 2 theta equals 2 sine theta cosine theta. So I'll distribute, or replace that. Then those 2's cancels. Those 2's cancel. That sine of theta cancels with 1 on top, and I'm just left with sine of theta over cosine of theta, which equals tangent of theta, which is what we wanted. So we're good. Whoa. I do not know what happened with that arrow. Sorry. Okay, last one. So you have sine of 2 theta equals 2 tangent of theta plus 1, or over 1 plus tangent squared of theta. I'm going to work on the right side, and I'm going to change it to sines and cosines. So we'll just start with the top. So that will be 2 times sine theta over cosine theta. And then the bottom, I'm going to also replace that tangent squared of theta with sine squared of theta over cosine squared of theta. Create one fraction down there, so I'm going to change that 1 to cosine squared of theta over cosine squared of theta. So that becomes cosine squared of theta plus sine squared of theta over cosine squared of theta, which that is 1. Cosine squared plus sine squared is 1. That's something you should have memorized. And then I'm just going to rewrite this as 2 sine of theta over cosine of theta divided by 1 over cosine squared of theta. If you divide by a fraction, you can flip that fraction and multiply. So that's 2 sine of theta over cosine theta times cosine squared of theta over 1. That cosine theta will cancel with 1 on top. So you're left with 2 sine of theta cosine of theta, which is sine of 2 theta, which is what we wanted. So we're good. Okay, take the quiz. I will see you guys when I see ya.